Hi students, welcome to Max Point of View. Today we are going to solve each and every previous year questions from the chapter Current Electricity. Before watching this video, my suggestion is current electricity has three different parts. Part A, Part B and Part C. In all the three parts we have concept, we have theory questions and we have numerical questions, correct? Learn all the solutions from these three parts, then only this video will be very useful for you. If you haven't seen those videos, all those videos are available in the description box. Then you will understand how the board exam questions, these are the board exam questions, right? How these questions are different from the textbook questions and how to tackle these questions using the textbook knowledge. When you get the knowledge from concept, theory as well as numerical solutions, you almost get 50 to 60% of the knowledge. Remaining things are these previous year papers as well as the logical and application. All those videos are available in the description box. And we know we have taken questions from 2017 to 2025. Why not before 2017? Because the questions were very direct and only few questions were logical. Now only few questions are direct, many questions are logical. Second thing is the syllabus was before 2016 was completely different from present case. Why not beyond 2025? Because this is the current year 2025. So without wasting any time, we'll start with our first question. Now we'll start from 2017. In that first question, define specific resistance and state its SI unit. See, many students they still have confusion that what is the difference between resistance and specific resistance. Okay, first we'll try to define it, then we'll understand using the definition. Specific resistance is the resistance of a material of unit length and unit area of cross section. Did you understand anything? But if you understand it in a proper way, the definition will become easy. There is no need to by heart. See, you take a wire. Okay, this is the length of a wire, this is the thickness of the wire. Okay, if I increase the length, what happens to resistance? Resistance also increases. If you increase the length, resistance also increases. If you increase the thickness, that is nothing but area of cross section are reduces. So length and area are changing. If the length and areas are changing, then resistance also changes, but resistivity remains constant. Why? Because what is resistivity? Resistivity or specific resistance is the resistance of a material for unit length and unit area of cross section. What do you mean by that? You take 1 centimeter length and 1 centimeter square area, that is thickness. For 1 centimeter length and 1 centimeter square of area, what is the resistance? That is specific resistance. Only for 1 meter length and 1 meter square area, what is the resistance? That is specific resistance. After that, if the length and area increases or decreases, we don't care. So specific resistance is a fixed resistance for a material. Okay, if you take 1 meter length of iron rod and 2 meter length of iron rod, the specific resistance remains same. Why? Because we are calculating it for 1 centimeter length and 1 centimeter square area. For this unit length and unit area of cross section, what is the resistance? That is specific resistance. After that, if anything changes, okay, specific resistance remains same. So to understand this better, see, resistance depends upon specific resistance. Resistance depends upon specific resistance. If the specific resistance is more, then the resistance will be more. But okay, so this one, specific resistance does not depends upon resistance. Okay, whether resistance increases or decreases, specific resistance of a material remains same. But when it comes to temperature, what happens, that we have learnt in concept video, correct? That is very much important. That is why I always tell you, for when it comes to previous year papers, okay, you have to first learn the concept and come. We should know everything about specific resistance. Here we are going to tackle with the different kinds of questions. Okay, so these are the basics of specific resistance. So what is now, I try to understand specific resistance is a resistance of a material for unit length and unit area of cross section. That's it. Now they are asking for its SI unit. So SI unit will be ohm meter. Resistance SI unit is just ohm. Okay, specific resistance or resistivity, both are same. Okay, so here ohm meter is the SI unit of specific resistance. Our next question, an electric bulb of resistance 500 ohm, resistance 500 ohm. See, now you will get to know how the board exam numericals are very simple. You will get to know. Only few numericals are little tricky, but simple only. If you know the method, aramse we can solve it. Now an electric bulb of resistance 500 ohm draws a current. Current is equal to 0.4 amperes. Calculate the power of the bulb and potential difference at its end. Okay, we need to calculate power and potential difference. You can find anyone. Okay, first, because power also, you for power I and R, we can aramse using these two we can find the power value. For voltage using these two we can aramse find it. So you can find anything first. Okay, we'll go for voltage first, because using the voltage and calculating the power will be easy. So voltage is equal to I into R. Okay, what is the value given? I 0.4 into R, that is 500. So for 0.4 you can do whatever the method you know, you can go for it. Answer will be 200 volts. So for voltage is done, then we have to go for power. Power is equal to V into I. Okay, okay, what is V? That is 200 into 0.4, that is 80 watt. Power is equal to 80 watt. See, this is not the only formula for power. Power is equal to I square R. This is also there, I square R. You can use that formula also. In that formula also you get the same answer. So whichever is easy for you, you can go for it. Now we'll move on to 2018. In that first question, you have three resistors of value 2 ohm, 3 ohm and 5 ohm. Three resistors are there. Okay, 2 ohm, 3 ohm and 5 ohm. How will you join them so that total resistance is more than 7 ohms? See, this question is very easy. Why? Because we just see, we have to make the resistance value more. If you want more resistance value, just add them. When we add them, when they are in series. So listen, if you know series, what is series connection and what is parallel connection, then these kind of questions are easy. That's why my suggestion, always watch the concept video and then come to this. Okay, concept, theory, numericals, you have to solve everything and come back to this. Okay, now listen, all these things are connected in series. We have to connect in series to make the resistance value more than 7. So we have to make the resistance, final resistance, that is equivalent resistance as more than 7. Okay, now if you connect any one in parallel or all the three in parallel, then you are not going to get the answer, correct? So you have to think properly. If they are asking, see, if you add all the three, you will get more than 7 when we add them when they are in series, correct? Like this you need to think. Then if assume the same question, so first we'll solve this question, then we'll try to go for a same, using the same value, how can the different questions can be asked. So we got to know we need to add them, because when we add them it will be more than 7 when we can add them when they are in series. So like this. Okay, 2 ohm, 3 ohm and 5 ohm. See, this is the diagram. They are also looking for the diagram. Okay, and calculate the equivalent resistance. For the first question, what is the first question? How will you join them? So in series. in series is the answer for the first question. Second question, they are looking for the diagram, and in the diagram they are in series. So 2 plus 3 plus 5, it is 10 ohm. It is more than 7. Now if they ask you, how can the same resistors can be connected so that final value, okay, less than 5, final value less than 5 ohms, now see, so we need what? Equivalent resistance less than 5 ohm. That means it should not even 5, okay, it should be less than 5. See, you can go for trial and error method. See, these two are in, okay, these two we can connect it in series and this one in parallel. See now, these two are in series, okay, 2 ohm, 3 ohm, 5 ohm. Okay, you have to try these kind of questions. In the textbook, we have some questions. If you try those questions, you will understand. See now, how I got to know about this question? When you try more and more questions, then you will get it easily. See, using all the three, we should get less than 5. Less than 5. See, now these two are in series, correct? So these two becomes 5 ohm, 5 ohm, and this one is these two becomes 5 ohm, and this is already 5 ohm. 5 ohm and 5 ohm parallel. Okay, what will be the effective resistance? 2.5. This is one trick. When two resistors are in parallel and they have same values, then if they are parallel, then final resistance value will be half of it. So these two, see, these two resistors are in parallel, correct? But these two values are not same. But when you add these two, first we need to go for series, right? So 2 plus 3, 5. 5 and 5 are parallel now. Once these two are parallel, okay, and they have same values, half of the values, okay, you have to take half of the value. So final value equivalent will be 2.5 ohm. Okay, you can go for the calculation also. Okay, these two becomes 5, 1 by 5 plus 1 by 5. So you take the final answer reciprocal, the answer will be 2.5. What if the same question asked in different ways? Okay, they have given the same resistor, 3 resistors, and the effective, the final answer should be less than 1. So equivalent resistance should be less than 1. Now here, okay, if you add anything, it becomes more than 1. So we should not go for series. You have to think like this. If you add any one resistors, it will be more than 1, correct? So assume now here in this case we have taken these two as series and this in parallel, correct? Now in first case all the three are in series. Why? Because the effective resistance requires it should be more than 7. Here it should be less than 5. Now they are asking, okay, how can it be less than 1? So very simple. Okay, if they want all the resistance value less than 1, always go for parallel connection. Okay, 2 ohm, 3 ohm, 5 ohm. So if you go for it, 1 by 2 plus 1 by 3 plus 1 by 5, finally you take the reciprocal, answer will be 0.96 ohm. That's it. Like this you need to think. So this is the main advantage of watching the previous year questions videos, not the solutions. You will get all these solutions in the Google. So in Google they will give you the perfect answer only for this question. Who will train you in all the angles? That is very much important. That is where maths point of view plays a major role. Our next question, find the equivalent resistance between A and B, and we have one more sub question. Sub question we'll go for it later. First we'll try to answer this one. Here more than the numbers and which one we have to do first, we have to see between which point they are talking about. They are talking about A and B. A is at this end, B is at that end. Then we go for normal method only. But if the A and B are in middle, see, assume I'll give you one question. This is question number 18 and 19 in textbook numericals. Okay, assume 2 ohm, 2 ohm, 2 ohm and 2 ohm. Here also we have resistors. So this is A, B, C, D. Okay, now in the same question, if they ask you to find the effective resistance, the normal method, everything is in series. What if they ask you to find effective resistance between the point A and C? A and C, this is a different method. Okay, then B and D again, if they ask you find the effective resistance between B and D, that's a different method, and A and D different method, B and C between the points B and C different methods. That's why in the same question these points are important. If it is at one extreme end and other extreme end, it is very easy. If you want to know these kind of questions, okay, that is numerical number 18 and 19, question number 18 and 19, you will understand the difference. Now we'll go for the exact question. Now see, we cannot go for series anywhere, correct, because these two are in parallel, these two are in parallel. First, always whenever these kind of questions are given, try to find the series connection. Do we have any series connection? First, no, then go for parallel. Now listen, these two are in parallel, so 1 by 6, 1 by 3, okay. So LCM will be 6 and this will be 3, so this will be 1 by 2. 1 by 2 is nothing but we have to take the reciprocal, because we are not finding parallel resistance, we are finding 1 by Rp. It is 1 by Rp, we have to take the reciprocal. Next we'll go for this one, 1 by 4 plus 1 by 12. The LCM is 12, so this becomes 3 plus 1, that is 4. 4 by 12, it is not, we have to take the we will try to cancel 1 by 3, we have to take the reciprocal, right? That is 1 by 3 becomes 3 ohm. So these two we have separately calculated, correct. Then finally these two becomes one resistance, that is 2 ohm, and these two becomes one resistance, that is 3 ohm. So then they'll be like this, correct, 2 ohm, 3 ohm, then these two are in series. So when these two are in series, answer will be 2 plus 3, 5 ohm. That's it. Next we have one more sub question. State whether the resistivity of a material wire change with the change in thickness of the wire. Just now we have learned resistivity of a material does not changes with length and thickness, or that is nothing but area of cross section. Thickness is nothing but area of cross section, length is, you know, okay. If these two changes, specific resistance or resistivity, both are same, okay. Resistance changes, but resistivity or specific resistance never changes with length and area of cross section, but specific resistivity changes with temperature. That too for conductors or metals it is different, semiconductor it is different, and insulator it is different. That we have learnt in concept video. When it comes to length and area, specific resistance or resistivity will not change. So answer for the question is, state whether the resistivity of a wire changes. No, it will not change, or you can write it as it will not change, that is also fine. Now we'll move on to 2019. So calculate the equivalent resistance for this diagram. See, again here they are talking about A and B, that is okay. Now see, first always find the series connection. These two are not in series because there is one more wire connected here. These two, we can aram say these two are in series. Whenever you find a mesh, okay, a square shape, rectangular face, okay, the shape, all those things, go for it. Okay, here this is single, we cannot do anything. After solving all these things, this become, all these three resistors become one resistance, then these two will be in series. So first we have to solve these two. See, these two are connected series, correct, series. If there was one more wire like here, okay, then these two would have been parallel. Now there is no wire, these two are in series. These two will become 9 ohm resistance, correct. 5 and 4 ohm, 9 ohm resistance. 9 ohm is parallel with this one, correct. 9 ohm is parallel with this one. See, for these calculations and all, no mark will be given. So you can just write RP, or RS. First one, RS is equal to S represents series, okay, P represents parallel. These two are in series, so 9 ohm. Then RP is equal to 1 by 3, this is 1 by Rp, right, 1 by 3 plus 1 by 9, okay, 1 by 3 plus 1 by 9. Why? Because when the resistance are in parallel, this is the formula. This 3 and this ohm, when we solve these two, this becomes one resistance, that value will be 9 ohm, and these two are in parallel. So LCM will be 9, and 3 plus 1, that is 4 by 9. So finally we have to take the reciprocal 9 by 4. 9 by 4. See, once we take the reciprocal, this RP, this is the complete value is 9 by 4. The complete value is 9 by 4. Now this complete value is in series with this one. So final answer will be, okay, final answer will be 8 plus 9 by 4. 9 by 4. 9 by 4 is 2.25. 8 plus 2.25 is 10.25. That's it. So these questions, say in the numericals, we have solved many questions when it comes to resistance. Then you will get proper idea. First you need to understand which one we have to go, whether for series or parallel. If you get this idea, then solving again here in the at the end, don't forget to take the reciprocal. Our next question, this is also diagram based, but compared to previous one, there is only effective resistance. Here we have to calculate resistance, current, all those things according to the question. Now understanding the things which they have given in the diagram is very much important. Battery voltage is nothing but EMF, okay, and the resistance of the battery is considered as internal resistance. The symbol is small r. Then these are external resistance, the symbol is capital R. These are the external resistance, this is the internal resistance. You should know the difference, okay, and using the resistance and this voltage we can aramse find the current. And so you have, whenever we are calculating the resistance value, we have to include this resistance also. Keep that in mind. Many students will not see this one only, they only focus on the external resistance. This one also we should include in the this one calculation. Now listen, now assume the rest, okay, key is not here, assume the key is somewhere here. This is one hypothetical situation. Listen, key is not, according to the diagram, key was here. I have changed the position. Now if the key is here, when it is open, the current will not enter. Current will not enter. See, when you get to know when the current is not entering the circuit, the resistance will be infinity. The infinite resistance. Answer will be infinite resistance. Assume the key is here. Okay. When it is open, the current will not enter. Current will not enter. If the current is not entering, the resistance will be infinite. The resistance will be infinite. Keep that in mind. When the resistance will be infinite, when the main key, this is main key, correct? Main, how can I say this is main key? Because this is the main key. If it is open circuit, current will not even enter. That is why we call it as main key. If it is about main key, okay. See, main key, where are the positions of main key? Next to the battery or this side next to the battery, okay. These two keys are considered as main keys. When these main keys are open, current will not enter, okay, then the resistance will be infinite. Keep that in mind. So what is the position of main key? The key has to be next to the battery, either this side or that side, then it is considered as main key. If the main key is open, current will not enter, then the resistance will be infinite. Now we'll go to the exact question. Now the key is here, this is not main key, okay, this is just a key which is placed between the circuit, okay. Now we'll go for the question. The resistance of the circuit when the key K is open. When this is open, okay, when the key is open, in that path the current will not enter. That you should know. Current goes from here, okay, enters here, but it will not go in this way because the key is open. So current will not enter this one. So current will only enter here. So it goes like this and comes back. Okay. Now at this case, okay, what is the resistance? This is 5 ohm resistance and this is 0.5. Whenever these two are in series, see all this one internal resistance always add to the external resistance. That's it. So first find the external resistance. If the current was going here, okay, then this will be the external resistance. We have to find the complete resistance value, then add it to internal resistance. In the same way, now here the current is not going, only these two resistance are there, we have to add them. Internal resistance, finally you have to add them. Keep that in mind. So 5 plus 0.5 will be equal to 5.5 ohm. See, when it comes to calculation, okay, this is all the sub questions. There are 4 sub questions, right? Every sub question carries 1 mark. So we don't care much about the step part, okay. Steps, final answer is important, and here if we get to know 5 plus 0.5, then we will give you the full marks. Sub question B, the current drawn from the cell when the key is open. Now the key is open. What is the resistance? 5.5. In this case, what is the current? Current is equal to voltage by R. Okay, voltage or EMF, anything is okay. EMF by R. R just now we found. So what is the voltage given? 3.3 divided by 5.5. Answer will be 0.6. What is the current unit? That is amperes. Next, we'll go for third sub question. The resistance of the circuit when the key is closed. Now the key is closed. Now the key is closed. When the key is closed, the current enters here and divides. Correct. Now it goes in both the circuits. Now find the resistance. 2 plus 3, 5. These two are in series. First we have to solve these two. 2 plus 3, 5, and again it is in parallel with 5 ohm resistors. In one of the questions and in numerical solution, I taught you one trick. When two resistors are parallel and their values are same, parallel value at the end final value will be half of it. See, this one you need to apply only when the two resistors are in parallel or three resistors are in parallel and all the values are same. See here, 2 plus 3, 5. 5 ohm is parallel with 5 ohm. Then final, if they are now they are in parallel, right? Then final answer will be half of 5. Half of 5, that is 2.5 ohm. So answer for the third question is 2.5 ohm, or else you can go for normal method also, 1 by 5. Because of these two, 2 plus 3, 1 by 5 and 1 by 5. You go for it, you will get the same answer. See, I'll show you. So here we have to take the reciprocal, that is 5 by 2, that is 2.5. Okay, you can go for the trick or direct calculation, anything is fine. Okay, the last one, current drawn from the cell when the key is closed. Now the key is closed, we have the resistance value, we have to find the current value. Again, current formula E by R. E remains same, that is 3.3. What is R? That is 2.5. When you solve this one, you will get 1.1 amperes. That's it. So first to calculations are easy. You need to understand what when the key is closed, what happens, when the key is open, what happens, all these things you should know. Now we'll move on to 2020. In that first question, what are superconductors? See, we have a few more sub questions. We'll go one by one. What are superconductors? Superconductors are the substances of zero resistance. The substances or materials have zero resistance or infinite conductance. Resistance is inversely proportional to conductance, right? So if a material has zero resistance or infinite conductance at very low temperature, this word is very much important. At very low temperature, these kind of materials or conductors are called superconductors. So very simple, the resistance of the wire will be zero. That means infinite conductance when it is possible, when the temperature of the material is maintained at very low temperature, very low temperature. For example, you can take mercury. Mercury, they have to maintain 4.2 Kelvin. 4.2 Kelvin, mercury becomes superconductor. Mercury becomes superconductor. 4.2, do you think it is easy? No, 4.2 Kelvin is minus 269 degrees Celsius. Minus 269 degrees Celsius. We have to maintain the temperature, then only mercury becomes superconductors. If it is a superconductor, then the resistance will be zero. It has high conductance. So that is an example for superconductor. Next we'll go for the second sub question. Okay, A is done. Then we'll go for B. Okay, calculate the current drawn from the appliances. Current we need to find. Power is given 110 watt. Voltage is given as 220 volts. Okay, now we know power is equal to V into I. We require I, so I is equal to P by V. P is 110, volt is 220, so this is 0.5. Unit of current is amperes. That's it. Name the substance whose resistance decreases with increase in temperature. So they are talking about resistance. See, when it comes to resistance and specific resistance, there is a relation. Okay, they can talk about resistance for these kind of questions or specific resistance also. So name the substance whose specific resistance or resistance decreases with increase in temperature. So this one we have learnt in concept video. So for the answer for this question is semiconductors. in semiconductors, okay, resistance decreases with increase in temperature. Example, silicon. Okay, so this is one example. We can take it as germanium. Okay, so these are the examples. If you write semiconductor also, you'll get marks. So in specifically you can write silicon and germanium. So this one, definition, calculation, and one logical question. Our next question, calculate the total resistance across A and B. So first we need to find whether do we have any series connection. So we don't have series connection. First we'll go for parallel, then these two will become one resistance that will be series with this one, then we can add them finally. So this 1 by 3 and 1 by 6, okay, 1 by rp, right, 1 by rp, these two are in parallel. 1 by 3 plus 1 by 6, answer will be 3. So it is 1 by 2, we have to take the reciprocal, so that is 2 ohms. This 2 ohms is in series with 5 ohms. So effective resistance or equivalent resistance is equal to 2 plus 5. This 5 is in series with these two resistance, correct. After solving these two will become one resistance that will be in series with this 5. So answer will be 7 ohm. That's it. Final answer is 7 ohm. Our next question, the diagram above shows 3 resistors connected across a cell, okay, as shown in the diagram, of EMF 1.8 volts and internal resistance R. Calculate, first we have to calculate the current through 3 ohm resistance. Only in 3 ohm resistance what is the current, and we have to find the internal resistance R. Every time R value we will be given, and this time they are asking. Very simple. If we know the formula, then we can aramse solve it. Listen, first we need to understand what is the first question. Current through the 3 ohm resistors. Where is that 3 ohm resistors? Here, correct. Whenever they are talking about current, they talk about parallel connection. Okay, whenever they ask you to find about current in a particular resistor, it has to be parallel. In parallel connection only they will talk about current. In series connection, if it is a series of resistors, they will talk about voltage, because we know in parallel connection current divides. That's why they will talk about current. In series connection, if the bulbs are there or if resistance are there, if they are connected in series, they talk about voltage. Keep that in mind. Now anyhow, in this question is about current, that too through 3 ohm resistors. 3 ohm resistors is parallel with this one, right? We have to consider these two resistors to calculate the current value, and we should not include this one. If they are asking effective resistance, then we have to go for a normal method, finding these two are in parallel. After that this becomes in series, all those things. Now understand the question, current through 3 ohm resistor, that means we have to find the current only in 3 ohm resistance, but that is in parallel. Whenever the current 0.3 enters here, it will divide 0.3, some value will go here, some value will go here. If the less resistance is there, more current will go here, less current will go here, correct. So we need to find what is the current in 3 ohm resistance. So for that we need to have both the resistors. We need to include both these resistors, because based on these two resistors only current will get divided. So we have to include. See, keep this in mind. Whenever they talk about current in any particular resistance, if that is in parallel, we have to find a complete parallel effective resistance that we are going to use. Keep that in mind. Okay. So we have to find the current through 3 ohm resistors. See, we need to find the current, correct. Whenever we want to find the current through any particular resistance, we don't use EMF. Keep this in mind. Whenever we try to find the current in a particular resistance, we don't use EMF. We require terminal voltage. Terminal voltage is equal to I into R. Okay, what is I? 0.3. To find, see, this all these methods, this is the current, complete current in the circuit. What do we require? Current in 3 ohm resistance. So to find current at a particular ohm, okay, resistance, we require terminal voltage, not the EMF. So this is 0.3 into R. What is R? R is nothing but these two values. Complete, only we have to take only these two. Why we are not including this one? Current in 3 ohm we require, that depends upon this resistance also. That's why we are including these two. We should not include this resistance. Assume there are two more resistors again parallel, then we have to include everything, as this resistance. Okay, this resistance we should not use because this is not related to this complete value. Okay, now Rp. So first we'll find this Rp. Rp is equal to 1 by 3 plus 1.5, we can take it as 3 by 2, 1.5 as 3 by 2, so that calculations will be easy. 1 by 3 by 2, right? So it becomes 1 by 3 plus 2 by 3, so it is 3 by 3, that is 1. If you take 1, that is 1 by 1. If you take the reciprocal again, it becomes 1 ohm only. So what is the Rp value? 1 ohm. So terminal voltage is 0.3 volts. So once we find the terminal voltage, we'll go for current at 3 ohm resistor. This is very much important. So listen, I told you to find this one, we require terminal voltage, that is V by R. What is this R? This 3 ohm resistance value we have to substitute. We should not include all the resistance. See, we are not including these two. We are not including this one. We are not including this one. We are talking about only 3 ohm resistors, right? So to find the current at that resistance, we need to use that resistance only. So it is 0.3 and by 3 ohm, correct? It will become 0.1 ampere. So when the current 0.3 enters here, 0.1 goes here, 0.2 goes here. Okay, more the resistance value, less current will flow. Less the resistance value, more the current will flow. So whenever we add these two, we should get 0.3 only. So this is the concept. Okay, now we'll go for the remaining questions. Okay, for the internal resistance R, we need to find the R. So we have a formula, E is equal to I plus R. Okay, I plus R plus R. What is this R? Capital R. Capital R, the complete resistance of the circuit. And this small r is the internal resistance. This is what we need to find, correct? First we'll find the proper equation, then we'll go for the substitution. So it becomes is equal to like this. Okay, so if we want to find the value of internal resistance, this is the formula. E we know, that is EMF 1.8. I we know, just know the I means current in the complete circuit, that is 0.3, that we know. Then R represents the every complete external resistance, all the external resistance represents R. So here these two are in parallel. We know, we have found it earlier. So that is 1 ohm. 1 ohm is in series with 4 ohm, so that becomes 5 ohm. So R value will be 5. Now we'll substitute and get the answer. R is equal to E by I. What is E? 1.8, I 0.3 minus this value. So whenever it is 1.8 divided by 0.3, so it is nothing but 3 ones are 3 6 are 6 minus 5, that is 1. What we are finding, internal resistance, the unit will be ohm. That's it. See, if you get doubt, just go back and rewatch it, you will definitely understand. Our next question, an electric iron is rated at 220 volts. Okay, so here 220 volts, and it is this is voltage and power is 2000 watt. Then if the iron is used for 2 hours daily, okay, find the cost of running it for 1 week. If it costs 4.25 rupees per kilowatt, for 1 kilowatt 4.25, then we have to find the electricity bill only for that electric iron, that is nothing but iron box. Okay, now so what is the formula for to find the bill value? Power into time into days into rupees. But here the condition is power should be in kilowatt and time should be in hours. This is the important condition. Number of days, whatever they have given it for 1 week, that means 7. If they are given for month, you should not think about February and January. February we have 28 days, January we have 31 days. If they talk about month, always go for 30 days. If they are talking about week, always go for 7 days. If they don't mention any days, you take the number of days as only 1. Okay, now we have to substitute the value. This one we have learned. This is a very simple question. Power is equal to power should be in kilowatt. They have given in 2000, okay, watt. 2000 watt is nothing but 2 kilowatt. 2 kilowatt, you don't have to mention it. Instead of 2000 you have to write 2, because it is in watt we have to convert in kilowatt. So divide it by 1000, so this will be converted into kilowatt. Hours, time, how many hours they have for every day? It is used for 2 hours. So 2 hours. Number of days, it is running for 1 week, that means 7 days. And what is the rupees value for kilowatt? Well, for 1 kilowatt it is 4.25. so now we have to find the value. Whenever we multiply all these things, 119 rupees. Now this is a very simple question. How can twist these questions? Okay, very simple. They will not give you power value. Power value will not be given. They will give you voltage and current value. See, using these two, see, voltage and current value will be given in the question. Using those two, we need to find, we'll say find power. Power is equal to V into I. If you substitute these two, which is given in the question, we'll get power. If you substitute that power here, everything will be wrong. Why? Because power should be in terms of kilowatt. So when voltage and current values are given, then divide it by 1000, then we'll get the power in terms of kilowatt. Then you substitute that value, you get the answer. Sometime if Vi is not given, okay, what is the other possibilities? I and R will be given. Okay, how using these two, how to find the power? Power is equal to, using I and R, that is I square by I square into R, you will get power value. Okay, then divide it by 1000. See, it is not always to find power. Okay, it is only for electricity bill. Whenever you want to find just power, these two are enough. Divide by 1000. Why? Because we have to convert into kilowatts here. That's why in normal questions, just to find power, these formulas are enough. No need to divide by 1000. Now, what if they give V and R? Using these two, how to find power? Power is equal to V square by R. V square by R, whatever the value you get, divided by 1000. So in this question, power is given directly. In some other question, they will give you these hints. Using these things, we need to find the power value. These things we have learnt in concept only. Okay, part C. Correct. Using these formulas, we can aramse find power. That power you should not substitute here, only when it comes to bill. When it comes to bill, this one power should be in kilowatt, time should be in hours. These are the some hints to solve different kinds of questions. And we have one more sub question. Okay, this is A is done. B. Why is the fuse absolutely necessary in a power circuit? So what is the function of fuse? Fuse is a safety device. Fuse is a safety device. Whenever an excessive current enters the circuit, okay, the fuse will melt and protect the appliances. That is why it is necessary in the circuit. So when the external current, okay, more current is there than the rated current, okay, then the fuse will melt and there is no connection between this side and this side, so it will protect the appliances. Now we'll move on to 2023. Here, this is a diagram based question. Here, if you see this one, many students will get panic. But if you know the concept, no calculations, no much calculation, logic is required. When the which key is open, which key is not open, those things you should know. And when the key is open, what happens? If the key is closed, what happens? That you should know. That is a very simple thing. Okay. First, what is the first question? When the key K2 is open and when key K1 is closed, this is closed. Okay, this is the symbol for closed circuit and this is open. This is the first condition. When this is the main key, correct? When the main key is open, no current will flow. No current will flow, correct? When the main key, this is the main key, this is not the main key, this is the main key, because if it is open, no current will enter. But now they have mentioned this is open and this is closed. If this is open, then no current will flow. We don't have to think about anything there. Okay, so if this is open, no current will flow. Then if the current is not flowing through the circuit, see, if the main key is closed, in one of the circuit also we have learnt, if the main key is open, no current will flow, then the resistance will be infinite. Write it in the full form, infinite resistance. Understood? So this is very much important. When the main key is open, no current will flow, the resistance value will be infinite. We don't care about all these things now. Okay, because this main key is only open, no current will flow, we don't have to find anything. Okay, next question. When the key K2 is closed, this is closed, this is closed, and this is open. When this is K1 is open and K2 is closed, see the main key is closed, that means current enters here. Okay, anyhow current enters till here, this key is open, that means current will not enter here, current will only enter in this direction, it will not go in upward direction because the key is open. Now anyhow the current is going in this way. See, these two are in series, 2 plus 8 10, 10 plus 1, finally you add this internal resistance. Okay, 2 plus 8 10, 10 plus 1 11. So what is the resistance? That is 11 ohm. Once you get the resistance value, if they are asking you to find the current in this path, okay, in this question for sub question B, current, we have voltage and we have current, aramse we can find the current in this circuit. See, we'll try to find that I is equal to E by R. Okay, complete R means internal resistance and the external resistance. We should not include these two. Why? Because current is not entering here. So E is 5.5 and R is 11. So answer will be 0.5 amperes if they ask you. Okay, then sub question C. When the both the keys are closed, okay, find the equivalent resistance, find the complete resistance in the circuit. Listen, when both the keys are closed, current will enter here and current will get divided, current will flow in both the directions because we have keys are closed, because the keys are closed. Now listen, so anyhow we have to take the complete resistance. 6 plus 4 10, 2 plus 8 10. See, these kind of things you have to be very careful. Then 10 ohm and 10 ohm are in parallel. I told you in earlier method, when two resistors are in parallel and they have same value, the effective resistance will be half of it. How much? Half of it. So here 6 plus 4 10, 2 plus 8 10. So then 10 and 10, 1 by 10 plus 1 by 10 will be equal to 5 ohm. 5 plus 1, how much? 6 ohm. So effective resistance will be 6 ohm. See, it is nothing but how we got 6 ohm? 1 by 10. These two are in series, 1 by 10. Then these two are in series, again it is 1 by 10. These two are in series, that's why we added 10 ohm. And these two are in parallel, that's why 1 by 10 plus 1 by 10 plus 1 ohm at the end, because it is external resistance. Now last one. So find the current when both the keys are closed. So for both the keys are closed, I is equal to E by R. E again remains same, that is 5 by 5.5, then divided by 6, it is almost 0.9 amperes. That's it. Okay, after the decimal, okay, try to get the first digit correctly. Second, two digits are enough. Two digits are after the decimal point, two places are enough to get the full marks. In that, first digit has to be proper. Our next question, define specific resistance. Okay, we have two more questions. See, the definition of specific resistance we have learnt in the first question, correct? Okay, what is the answer for that? Specific resistance is the resistance of a material for unit length and unit area of cross section. That's it. So the definition we have understood properly in the first question. Then we'll go for the second one. First question is done. Second one, what happens to the specific resistance of a conductor if length is doubled? We have learnt clearly that length and area, length, thickness, all those things will not affect the specific resistance. If it will only affect the resistance. Okay, specific resistance is nothing but resistivity. Resistivity will not get affected from length and area. It will only get affected from temperature, and we have learnt properly. See, when it comes to temperature, it is different for metals. So that is nothing but conductors, semiconductors and insulators. There you have to focus properly. Now what happens to the specific resistance of a conductor? No change. No change. So you can write it as it remains same. Okay. Remains same. Then sub question C. Name a substance whose specific resistance remains almost unchanged with the increase in temperature. See, when it comes to conductors, as the temperature increases, specific resistance increases. When it comes to semiconductors, when the temperature increases, the specific resistance decreases. But when it comes to this question, in this question, even though there is a change in temperature, name the substances whose specific resistance remains constant. So that is nothing but alloys. Alloys. When it comes to alloys, there are two materials. Okay, these are the two materials where even though the increase in temperature, their specific resistance remains constant. Constaton and manganese. These are the two materials. Our next question, calculate the current I. See, this is the diagram given. Okay, using this diagram we need to find the current. See, to find current, what do we require? Voltage is there, terminal voltage. See, to find current we require I is equal to E by R plus R. Okay, what is this R? All these resistors. What is this small r? That is internal resistance. So we have to include all the resistance. Then we have EMF. We can aramse find current. For that we need to find these resistance. Correct? How to solve this one? Do you see any series connection? Yes, we have series connection. See, these two are connected in series. These two are connected in series. When they are in series, 15 plus 15, 30. When these two becomes one resistance, that will be parallel to this one. That will be parallel to this one. So 15 plus 15, 30. 30 and 30 both are in parallel. See, if two resistors are in parallel, okay, I'm not taking these questions randomly. This is from this one board paper. So in board papers only parallel connection values are they are giving equally, so that calculations will be simple. Here 30 and 30, these are the two resistors are in parallel and their values are same. Then half we have to take the half of the value. 30 and 30, half is 15. 15 ohm is the effective resistance for these two, and this is 2 ohm. 15 plus 2, 17 ohms. It becomes 17 ohms. Now, if you want to find it properly, see first RS 15 and 15, that is 30 ohm. Okay, because these two are in series. Then RP, this is in parallel with these two. Correct? These two becomes one resistance. That value will be 30. That is what we found. Then 1 by 30 plus 1 by 30 will be equal to 2 by 30. 2 1s are 2 15s are. Finally we have to take the reciprocal, that is 15 by 1, that is nothing but 15 ohms. Okay, so 15 ohms is the resistance of all the three, then plus 2. Okay, so this is R value plus 2 will be 17. So E value is 3.4 and R value is 17. Once we substitute all these things, the answer will be 0.2 amperes. That's it. Okay, if you know the method, these kind of questions are very simple. So first you need to know R plus R. If you know this formula, you do it in any way, okay, calculation method or logical method, you will get the full mark. Then calculate the terminal voltage. What is terminal voltage? Terminal voltage is equal to I plus R. Here you should not include, whenever we are finding terminal voltage, you should not include this R, small r we should not include. Okay, V is equal to I plus I into R. What is I? Just now we found that is 0.2. What is R? R means these resistance. You should not include this one. Because of these three resistance, what is the answer? We got 15. Correct? So that is 15. So terminal voltage value will be 3 volts. That's it. Now we'll move on to 2024. Study the table. This is the table. Here voltages are given at different situations and currents are given. Okay, now state whether the conductor used is ohmic or non-ohmic. So if they are asking these kind of questions, there must be a condition. For ohmic resistance, ohmic conductors, see, keep this in mind, ohmic and non-ohmic. For ohmic, resistance value should be constant. What? Constant. It has to be constant. Okay, here resistance value should be variable. Okay, this is the condition for ohmic and non-ohmic. Now based on this one, aramse we can answer this question. 10 by 2. Okay, what is resistance? Resistance is equal to, see, what is the resistance formula? V by I. Correct? V by I. 10 by 2, 5 ohms. 20 by 3, you should get 5 ohms. Okay, if you get 5 ohms, then it is a ohmic, because in all the different calculations R should be constant. If it is constant, then it is a ohmic resistance. Okay, ohmic conductors. If it is R, if R is variable, then it is non-ohmic conductors. Using this formula, we have to find the resistance. So resistance is equal to, so R is equal to V by I, right? So 10 by 2. So 10 by 2 is, in first case it is 5. Here we'll write it 5 ohm. In second case 20 by 3. 20 by 3, it is 6.66. Okay, in the third one here it is 30 by 4. 30 by 4 is 7.5. Okay, do you think R is constant? See here, it is 5, 6.6, it is 7.5. It is increasing or decreasing? We don't care whether it is constant. No, it is not constant. So definitely it is a non-ohmic conductor. So answer for the first question is non-ohmic. See, don't write the reason here only. If they are asking for reason, then go for a reason. First question is about whether it is ohmic or non-ohmic. Correct. Identification is done. Then see the second question, justify your answer. Now we have to write the reason. Reason is very simple. Resistance in all the three different cases is not constant. That is why it is not non-ohmic conductors. Then third one, state Ohm's law. Ohm's law, we know, it's a very simple question. Current flowing through a conductor is directly proportional to the potential difference between the conductors when the temperature is constant. This word temperature and other physical quantities are constant. This is very, very important. Keep that in mind. Our next question, 5 bulbs are connected in series in a room. Okay, so you have to draw the diagram, or you can directly go with the logic. That is okay. Many students will not understand it properly. See, 5 bulbs. Okay, now one bulb is fused. One bulb is fused. What do you mean by fused? Fused means one bulb is not working. Fused actual meaning is inside that there will be a filament. Okay, that filament will melt. Okay, because of high current it will melt. That we call it as fused. Once it is fused, it will not work. Okay, in series connection, so which one we are going to select? They have not mentioned which bulb is fused. You can select this one, this one, this one, any one. Okay, first, last one or the first one, that doesn't matter. Now assume this fuse, this bulb 1 is fused, so it has been removed. This is the very important point. It is removed and remaining 4 bulbs are connected again. So this is very, very important. Okay, if they don't remove this one, all the remaining 4 bulbs will not get the power. They will not glow. These, keep this one in mind. Okay, we have 5 bulbs. Out of that, 1 is fused. If you don't remove this one, what happens? These 4 bulbs will not receive the power because they are connected in series. That is the main problem with the series. So if they are connected in series, if this is fused, if this is not working, all these 4 remaining bulbs will not also work. So what they have told, it is removed, so we will remove it, and the 4 bulbs we reconnected it in a series. Now this is the concept. In the same circuit, what will be the effect on the following physical quantities, whether it increases, decreases or remains same? That we have to mention. What is the first physical quantity? That is resistance. What happens to resistance? Do you think resistance increases or decreases or remains same? Actual answer is it decreases. Why? Because very simple, as the number of bulbs in series are more, the resistance will be more. See, these bulbs will have some resistance, correct? So this is considered as load. Load will have some resistance. As you keep on removing the loads, load is nothing but the appliances which uses electric power to work. Those we call it as load. More the number of loads are connected in series, then the resistance will be more. Because one bulb got fused, that was not working, we removed it. That means resistance reduces. So resistance will decreases. This is how you need to understand. Okay. Now intensity of the light. Intensity means what? brightness. What happens to the brightness of the bulb? See, brightness completely depends upon voltage. See, many people will say brightness depends upon, if you go for the solutions for all these things, they'll tell you current increases, that's why intensity also increases. Actual reason is, when it comes to current, that is correct, but it is little complicated. When it comes to intensity of the bulb or brightness of the bulb, always think about voltage, because voltage will give you instant answer. For current, we have to calculate something. Here, when it comes to intensity or brightness of the bulb, always think about the voltage. Now we know in series connection, voltage divides. In series connection, voltage divides. Correct. That means if I give 500 volts for 5 different bulbs which are connected in series, okay, it will get divided into 100 volt, 100 volt, 100 volt, 100 volt. Correct, 5 times. So now what happens? Now one bulb got fused. That means we assume we have passed 500 volts. Initially every bulb was having 100 volts when the all the 5 bulbs were working. Now one bulb was not working, we removed it. This 500 volts again divides by 4, so it will be 125. Now the voltage has increased. See, in series connection, voltage divides. Now initially we had 5 bulbs, now we have 4 bulbs. So the same 500 volts, okay, assume there is a 500 volts, now it has divided into 4, it is 125 volts. Voltage has increased, so if the voltage is increasing, brightness will increase. That is nothing but intensity of the bulb also increases. Keep that in mind. Always think about voltage in solutions. Okay, in Google and all, it will go for current only. Current will give you the proper answer only, but it is little complicated compared to voltage. So always go for, when it comes to intensity, always go for voltage. So in this case, as one bulb got fused, okay, we have only 4, voltage has increased, so intensity also increases. So in this way, we need to understand. See, in series connection, when we have more number of appliances, more resistance will be there. Okay, if you remove the appliances, resistance will keep on decreasing. Then as they are connected in series, okay, the voltage will, whatever the voltage we give, that will get divided. Okay, if you remove some appliances, again the voltage value, it will still divided, but it will the divided voltage will be little more compared to the previous one. If the voltage increases, intensity also increases. Our next question, see, this is 2024, this was asked for 3 marks. Okay, listen, see here internal resistance is not given, so this is one important thing you need to notice. Voltage, EMF is given and few resistance are given. We'll go for the question. Calculate the total resistance of the circuit. Okay, first one, see, total resistance, these two are in series, so 10 plus 6 becomes 16, 12 plus 6 becomes 16, then these two becomes parallel. And I told you many times that if two resistors are in parallel, if their values are same, okay, 16 ohm and 16 ohm, then resistance in parallel final value will be half of it. Or what is half of 16? 8 ohm. You can write it directly, or then you can go for a calculation. 10 plus 6 16 and 12 plus 4 16, these two are in parallel, so 1 by Rp is equal to 1 by 16 plus 1 by 16, it is 2 by 16, it is nothing but 16 by 2. You have to take the reciprocal, right? Now only I have taken 2 1s are 2 8s are, answer is 8 ohm. That's it. Second one, calculate the current drawn from the cell. Very simple question. We have resistance, we don't have internal resistance. If we had internal resistance, we have to add that internal resistance to find the current value. Then resistance is given, EMF is given, I is equal to E by R. What is E? 4. What is R? 8. It will be 0.5 amperes. That's it. Next, sub question C. State whether the current through 10 ohm resistor is greater, lesser than or equal to current through the 12 ohm resistors. We have two resistors. We are talking about 10 ohm and 12 ohm. Actually speaking, current will be more in the resistor which has less value. So 10 ohm resistor and 12 ohm resistor, they are talking about only these two. They are not talking about 6 and 4. They are talking about only these two, right? So if the resistance is less, current will be more. If the resistance is more, current will be less. Correct? That is the actual concept. But that is correct whenever these two resistance are not there. Okay, these two resistance are not there. And we know when the current enters here, it will get divided. It will get divided based on the complete resistance of this path and complete resistance of this path. Based on that, current will get divided. See, complete resistance of this path is 16 ohm and complete resistance of this path is 16 ohm. So current in both the paths resistance is same. So find what is the answer, whether the current through 10 ohm or 12 ohm resistors, that will be equal. Current will be equally divided. Why? Because in both the paths we have same resistance value. 12 plus 4 16, 10 plus 6 16. You should not see only about 10 and 12. You should see the complete path. You have to add. These two are in series, right? Add. Assume this is 10 plus 5, 10 plus 5, and this is 12 plus 4 as it is. So here it is 16, here it is 15 totally. Correct. Assume if this is 5, this will be 15 and this will be 16. Then the current will be more in 10 ohm resistance. 10 ohm resistance. Anyhow, in this case, present case, the resistance in both the paths are same. Current will get divided equally. So these kind of questions only they are going to see. Two questions are simple. One question is logical. Now we'll move on to 2025. A current flows through a metallic conductor for a long period of time. This is very important. Very important. Long period of time. Okay. So a current flows through a metallic conductor for a long period of time. State the change you would expect in its resistance and resistivity. First we'll go one by one. Okay, long period of time is important. See, when the current flows for long period of time, temperature increases. If temperature increases, what happens to resistance? Resistance also increases. You have to write it in full form. Resistance increases, or you just write the sub question A, increases. That is enough. You don't have to mention resistance also, because we know sub question A is related to resistance. Then we'll go for sub question B, that is resistivity or specific resistance. We know specific resistance, if the length and area increases, that will never change specific resistance. But here they are talking about current is flowing through a metallic conductor. Metallic conductor is also one of the key for resistivity. When it comes to conductors, specific resistance is directly proportional to temperature. That means if the temperature increases, specific resistance increases. So this is very much important. Specific resistance, or this symbol, okay, is directly proportional to temperature when it is conductors. If it is a conductor, okay, specific resistance, okay, is inversely proportional to temperature when it is come to semiconductors. Okay, and when it comes to this one, insulators, specific resistance is obviously high. So when it comes to insulator, it doesn't matter. But when it comes to alloys, in one of the questions we have learned, even though temperature increases, the specific resistance remains same. Okay, specific resistance remains same for alloys. What are those alloys? Manganese and constaton. Okay, those are the two alloys we learned. That is the only two alloys given in the textbook. So in this case, see, understand this question properly. A current flows through a metallic conductor for a longer period of time. Longer period of time means temperature increases. If temperature increases, resistance increases. Now when come to specific resistance or resistivity, resistivity only depends upon temperature, correct? And what kind of materials? Conductor, for it is given metallic conductor, correct? For metallic conductor, specific resistance increases with increase in temperature. That is why both the resistance and resistivity increases. In this way you need to understand. Whenever you get a small doubt, just go back and rewatch it. You will definitely understand. Our next question, so this is the diagram. We have three bulbs, B1, B2, B3, and we have given EMF of the battery. Now three identical bulbs, identical means everything will remain same. The power, voltage, resistance, everything will become same. That is the meaning of identical. B1, B2, B3 are each of power rating 18 watt and 12 volts are connected to a battery of 12 volts. Okay, now calculate the resistance of each bulb. Okay, first one we have to calculate the resistance of one bulb. Resistance of one bulb is equal to, how to find resistance using power and voltage? See, main formula will be P is equal to V square by R. V square by R. If current is not given, using power, voltage and power, we can find resistance. This is the formula. To find resistance, R is equal to V square by P. What is V? V given as 12 volts, correct? So 12 into 12 V square, right? So 12 into 12 divided by power. What is the power they have given? The power is 18, correct? When you solve these two, answer will be 8 ohm. That is the resistance of each volt. That's it. Very simple question. Just by applying the formula and substituting the correct values, you will get the answer correctly. Then current drawn from the cell. Current drawn from the cell. So what is the complete current in the circuit? For that we need to find, see, the resistance of each bulb we got to know. Correct, resistance of each bulb. Find the complete resistance. Okay, then we have voltage, EMF is given. See, I is equal to E by R. What is R? R is the complete resistance of the circuit. We know each bulb has 8 ohm. So here 8 ohm, 8 ohm and 8 ohm. These two are in parallel. Correct. These two are in parallel and they have same values, same resistance values. So 8 ohm, 8 ohm, 1 by 8 plus 1 by 8, answer will be 4 ohm. That 4 ohm is connected with series with this bulb, correct? So 4 ohm plus this 8, so that will be 12 ohm. So EMF will be 12 and resistance is 12. So answer will be 1 ampere. See this resistance, I'll do it here. These two are 8 ohm, correct? 1 by 8 plus 1 by 8. So answer will be 2 by 8. That is 1s are 4s are. We have to take the reciprocal 4 ohm. From these two bulbs we got 4 ohm. That is connected in series with this 8 ohm. So 4 plus 8, it will be 12 ohm. The same value I have taken it here. So EMF is 12 ohm, resistance is 12 ohm, current will be 1 ampere. Now sub question C. This is little tricky. If the bulb 3 is removed from the circuit, then what will be the brightness of the bulb 1? Whether it increases, decreases or remains same. See, in one of the question we have learnt, it completely depends upon voltage. Brightness completely depends upon voltage. Okay, now listen. So first, now we are not going to remove the bulb. Let it be like that. Now because of these two bulbs, B2 and B3, what is the resistance? 4 ohm, correct? 4 ohm. Now if I remove this bulb, then the resistance of this bulb is 8 ohm. That will be in series with this one. Then the resistance increases, and okay, resistance increases. This is one way to understand. If the resistance increases, brightness will reduce. This is one way to understand. Now I told you it mainly you can focus on voltage, correct? Now if you remove this bulb will be in series with this one. Then whatever the voltage we give, okay, in series connection, voltage will get divided, correct? Voltage will get divided. Now if there is no bulb like this, okay, if you remove this bulb 3, this bulb will be in series with this one, then whatever the voltage will I'll give, we know in series connection it will get divided. That means it is reducing, and brightness is directly proportional to voltage. If the voltage decreases, the intensity or brightness also decreases. In this way you need to understand the concept. So from 2017 to 2025 we have learned all the concepts, correct? If you go for website or Google, it will give you the solution. It will not explain it to you. Someone has to explain it to you, then only you will understand. We are not just explaining that particular question. What are the possible ways they can ask the same question? All those things we are learning. That is where maths point of view plays an important role when it comes to previous year papers. Okay, now we have solved all the questions. I think you have understood. If you get any single doubt, just go back and rewatch it. You will understand everything. After this one, go to the logical and application questions of this particular chapter, current electricity. Then you will understand the specimen paper questions as well as the competency based questions which is released by ICSE, that is ICSE board. In those paper also we have segregated chapter wise. Then you will understand it better. So concept, theory solution, numericals, then previous year papers and logical and application based questions. That is chapter wise, you will understand everything properly. Then whatever the questions they ask in the board exam, you will definitely able to answer it without fear. Thank you.